Up. Today we're doing the homework review. Brenda, you have a question?
Yeah. What does that AQ and that little kind of L mean?
All right, each bracketed letter symbolizes the state of the reactant. So if you put a G, it means it's gaseous. If it's L, it's a liquid, pure liquid. And AQ means something dissolved in water. And the other one that's not in here, so see this one here, solid. So we have solid, liquid, gaseous, or aqueous. Okay, so we'll start with the first one. We have carbon monoxide combining with oxygen to form carbon dioxide. There's one carbon on the left and one carbon on the right. There's 3 oxygens on the left and 2 oxygens on the right. So we're going to be forced to put either a 1/2 on the oxygen, or if you prefer, you can double all those quantities and put 2, 1, 2. Either one would be correct. I'm going to leave the 1/2 up there. For B, we have dinitrogen pentoxide reacting with water to form nitric acid. What would be the first thing you would look at to start balancing something like that?
Look at how many different elements you have. Each element.
Okay, you look at how many elements, you look at, what you do is you pick one element. Pick one element and start toying with that idea. For example, we have 2 nitrogens over here. There's no nitrogen in the water. So we're forced to balance this nitrogen by using the one product that we have on the right-hand side. So a good place to start would be to say, well, nitrogen, 2 nitrogens here have to be balanced by 2 nitrogens over here. So we're going to have to put 2 nitric acids. Then we worry about balancing the water and the oxygen. We'll see that if by writing 2 nitric acids, we're going to get 6 oxygens. Let's see if the oxygen balance. We have 5 oxygens here and 1 oxygen there. Is that going to balance? Yeah, 6 oxygens on the left, 6 on the right. Let's look at the hydrogen now. 2 hydrogens balancing with 2 hydrogens. So we balanced it by writing one number. One number alone was enough. So we got lucky. Had we started, suppose we had started with water instead. We'd say, okay, well, there's 2 hydrogens on the left, and we need to balance those hydrogens. And the only product we have on the right is nitric acid, which has 1 hydrogen. So let's write it 2. 2 hydrogens. See, so even though you started from 2 different spots, you got lucky on this one, and you get the correct answer anyway, because the 2 hydrogens are balanced. We have 2 hydrogens on the left, 2 hydrogens on the right, 2 nitrogens, 6 oxygens, 6 oxygens. So it worked. Let's do methane reacting with chlorine gas to form carbon tetrachloride and hydrochloric acid. There's 1 carbon here. Actually, I'd be inclined to start with the okay, we'll start with 1 carbon. 1 and 1. There's 1 carbon here, 1 carbon there. 4 hydrogens. Why don't we try putting a 4 here? Because there's no other source of hydrogens on the right-hand side. So 4 hydrogens. And of course, that's going to come with 4 chlorines. So we're going to have 4 chlorines there and 4 chlorines here. So we have to have 8 chlorines on the left-hand side. 4 Cl2. If I had started with the Cl2, I would have been tempted to say, well, see, there's 4 here plus a 1 there, so that's going to give us 5, and I would have wanted to put 2.5 Cl2s to give me the 5 Cls, but then the methane wouldn't have balanced. So we have to be judicious in what we pick to start our balancing with. Like I said, it's like learning how to tie your shoelaces. It's hard to teach, but once you get it, it's pretty straightforward. I could have started also with hydrogens. I could have said, well, there's 4 hydrogens on the left, there's no hydrogens from here. So let's say I put a 4 in front of the HCl. That's going to come with 4 chlorines, so therefore the 4 chlorines here and the 4 chlorines there is going to give me 8 chlorines on the right, so I'll put a 4 over there. So we could have gotten the right answer doing it that way as well. Let's look at D. Aluminum carbide with water gives you aluminum hydroxide and methane. We have 4 aluminums on the left and how many on the right? What would be a logical starting point there? Let's try putting a 4 in front of the aluminum hydroxide, see what it brings us. So we have the aluminums balanced now. And by doing that, we're also going to generate 12 hydroxides. 12 hydroxides. And we have to balance the carbon. Let's balance the carbon first. We'll worry about the hydroxides after. There's 3 carbons here, so we absolutely must have at least 3 methanes. By putting 3 methanes, we have 3 carbons, and of course we're also going to have 12 hydrogens. Oh, that's a good sign. 12 hydrogens with 12 hydroxides. If you combine hydroxide with hydrogen, what do you get?
Water.
You get water. So we want 12 waters, and it'll take care of all our problems. See? The 12 hydroxides come from here, the 12 hydrogens come from there, so the math all works out. Now let's just double check. 4 aluminums, 4 aluminums. 3 carbons, 3 carbons. 24 hydrogens, you have 12 hydrogens here and 12 hydrogens there, that's 24 hydrogens. 12 oxygens, 12 oxygens. That's what it balances. Here we have what looks like probably an ester. It's a liquid mixing with oxygen, and so it's burning. It's a combustion reaction because we have carbon dioxide and water forming. We have 5 carbons over here, so we must put a 5 in front of the CO2, minimally. Nothing else. And then we have 10 hydrogens, so let's put a 5 in front of the water. Remember, when we have combustion reactions, it's very easy. You balance them alphabetically. First carbon, then hydrogen, then oxygen. So we've done the carbon and the hydrogen. Now we're going to balance the oxygens. 10 oxygens here, plus 5 oxygens here is a total of 15 oxygens on this side. How do we get 15 oxygens? Remember, we already have 2 sitting over here, so we actually only need 13 from over here. So we're going to say 13 over 2. Some people don't like fractions, so we can double everything. 2, 13, 10, and 10. Let's see if it works out. 10 carbons, 10 carbons. 20 hydrogens, 20 hydrogens. 4 oxygens plus 26 oxygens is 30 oxygens. On the left, 30 on the left. 20 plus 10, 30 oxygens on the right. So it balances. Okay, when you get good at it, you'll get a lot faster. Yes, Oscar?
Why did you put a 2 for the carbons on the left side?
I put a 2 here because when I originally balanced it, it was 13 over 2 for the oxygens. And just to make it less messy, I got rid of the fraction, so I doubled everything. All right, so on the next one, we have ferric hydroxide, Fe iron 3 hydroxide, reacting with sulfuric acid to give you ferric sulfate and water. You have 2 irons on the right. You notice I usually just start on the first atom. 2 irons on the right means I'm going to have to put a 2 over here for sure. If I put a 2 over here, that's going to generate 6 hydroxides. So my bet is that if I put 6 waters, I'll get the 6 oxygens I'm going to need, and that's going to force me to have 12 hydrogens on the left. Let's see how many hydrogens I already have. I have 6 here from the ferric hydroxide, so if I put a 3 in front of the H2SO4, it should work out. And sure enough, it does. Look at how you get 2 irons, 2 irons. 6 hydroxide, okay, let's not worry about hydroxide just yet, let's skip to the sulfates. 3 sulfates, 3 sulfates. Notice how I just looked at a whole group at once. See, sulfate, that's one piece of the reaction. 3 sulfates, 3 sulfates. So we're okay with the sulfates. Now let's look at the hydrogens. We have 6 hydrogens here, 6 hydrogens here, that's 12 hydrogens on the left, and 12 hydrogens on the right, so it works out. And for the oxygens, we have 6 plus, we took care of the sulfates, so we don't have to worry about that. Yeah, so we're just looking to look at that.